Hey everybody, just want to welcome you to week 6, module 6 for ME 144 heat transfer. So in this module here, what we're going to do is we're going to finish wrapping up chapter 3 with the topic of one-dimensional steady state conduction. We're going to go through some practical applications and take a look at some hand solutions to some example problems from the book. Now, a couple of bookkeeping items for this week right here. We have quiz number 6 has been posted to Blackboard, and this will be due on Friday the 12th by 4 p.m. Also, you have your homework number 3. This will be assigned on the 8th. In the morning, it'll be released on Blackboard, and it'll be due the following Monday by 11 p.m. Now, just a reminder, I have office hours scheduled on Mondays from 9 a.m. till 10 a.m. Now, if you're unable to meet during these times, please send me an email or a message or a chat through Teams. We'll find a time that does work. Also, a reminder, there are 2 other sets of office hours for this class as well, hosted by the TA, and these are on Mondays and Wednesdays from 11 to 12 p.m., and here's the contact information email for the TA. So there's 3 sets of office hours for you guys available, so if you have any questions, content, homework, grading, any of that, please contact one of us during these office hours. Now, as we jump into Module 6, we wrap up Chapter 3, what we're going to be looking at is extended surfaces and the bioheat equation here. So within this module, we're going to take a look at heat transfer from these different extended surfaces, see our governing equations in theory, take a look at our bioheat equation, or heat transfer within the human body, talk about muscle and skin, and also we're going to take a look at some thermoelectric power generation and conduction on the micro and nano scale. So within this module, we'll go through the extended surface, governing equations, a couple practical applications, some example problems, talk about the bioheat equation, go through some thermal power generation, and then micro and nanoscale conduction. Now, if you're relating this back to your required readings in your textbook, this goes from Chapter 3, finishing it up from Section 6 through 9, and Section 10 is the summary as well that I would recommend reading through. So we'll break this module down into 2 different sections here. The first module is going to be Module 6.1, where we're going to focus on our extended surfaces. So within this here, an extended surface is something that's going to involve heat transfer by conduction within a solid and heat transfer by convection and or radiation from the boundaries of the solid. Now the difference now here is that the direction of the heat transfer from the boundaries is going to be perpendicular to the principal direction of the heat transfer in the solid, which is a little bit different than what we've seen before for typical convection. So this is just for the special case of these extended surfaces. We'll be looking at some fins and things of that nature. So speaking of that, as we get into our objectives, we're going to talk about the general conduction analysis first. Then from there, we're going to take a look at our fin equation, go into some fin performance parameters. From there, take a look, what if we have an array of fins, and next take a look at our surface efficiency as well. So key activities, go over these governing key equations, see how we can apply them to specific problems, and then go through some of my hand solutions to a few different example problems. So next we'll move on to Module 6.2. We'll start with our bioheat equation within this here. We'll also again talk about the thermoelectric power generation, and then we'll look at conduction through thin gas layers and thin solid films as well. And with this here, again, go through our governing equations, talk about how to apply them to certain specific problems, then go through some problems and take a look at my hand solutions.